All right, today we're doing 2.A, polynomial functions of a higher degree. So just to refresh, the graph of a polynomial function is always continuous. This means that it has no breaks, no holes, no gaps. So it's continuous. You could draw the whole thing without picking up your pencil. This would not be a polynomial function because it has that gap there. This one is a polynomial function because it has smooth, rounded curves. Functions that have sharp terms are not polynomials. This would be like an absolute value graph. It's not a polynomial. So it just wants us to do a rough sketch of these three graphs. So let's try negative x cubed. So we know that x cubed looks something kind of like this, right? So if we're looking for what negative x cubed looks like, we're just going to come the other way. Like that. The next one is x to the third plus 1. So since we know what x to the third looks like, all we're doing is we're shifting it up 1. Like so. And then the third one is x minus 1 cubed. This means, remember, anytime that it's in with the x, that's our trickster. So we're moving left and right. So this one's going to not go left, it's actually going to go right 1. So we move it to the right 1. And so we're going to look like this. And those are our rough sketches of our polynomials. Okay, so we are getting into our leading coefficient test. And so what this says is that as x moves to left or right, the graph of the polynomial function, we have this general equation where n is our highest exponent and an is our leading coefficient. So it's saying when n is odd, so when your highest exponent, another word for that is degree, is odd, so 3, 5, 7, or whatever, then it follows these categories. If the leading coefficient is positive, so that number in front, then the graph falls to the left and rises to the right. And what happens in the middle could vary depending on the graph, but we know that that's at least the direction it's going to take. If the leading coefficient is negative, then the graph rises to the left and falls to the right. If the leading coefficient is positive, the graph rises to the left and to the right. If the leading coefficient is negative, then the graph falls to the left and falls to the right. So it says, use the leading coefficient test to describe the right-hand and left-hand behavior of the graph, negative x cubed plus 4x. So let's see, what is n? N is our highest exponent. Our highest exponent is 3. And what's our leading coefficient? Our leading coefficient is whatever number is in front of that highest exponent. So in this case, it's a negative 1. So we have an odd n and a negative leading coefficient. So then we go to our chart and we look at it. Okay, we go to odd and then negative. We know that it rises to the left and falls to the right. And that's all we have to put for this question. That's our answer. The next one says, use the leading coefficient test to describe the right-hand and left-hand behavior of the graph of each of these functions. Okay, so let's look at A. What is our exponent here? What is our highest exponent? Our degree, or our highest exponent, is 4, which is even. And our leading coefficient is 1, which is positive. So we're looking for an even positive. Even positive rises to the left and right. It's going up on both ends. All right, for part B, the leading or the degree is 5 and the leading coefficient is also 1. So we have an odd number and a positive. So we go to odd, positive, graph falls to the left and rises to the right. So we can kind of get an idea of what is going on within our graph from the leading coefficient test. Okay, last thing we're talking about is zeros of a polynomial. So this is just saying that all of these are mean the same. So x is a zero, a solution, a factor, an x-intercept, All of these words are synonyms. They're all meaning the same thing. So if it asks for any of them, you're doing the same steps. So this first thing says, find all the real zeros of x cubed minus x squared minus 2x. So we do this by factoring. We can pull out an x here to start our factoring process, and then we can figure out what multiplies to give negative 2 and adds to give negative 1. So that would be negative 2 and positive 1. And then we can solve here. We know x equals 0, x equals 2, and x equals negative 1 there. And so we can actually solve, and we know that these are all of our zeros, or our x-intercepts, or our solutions, or our factors. All of these are our answers. We could double check them by plugging them in and making sure that they come out as 0. If you plug in 0, you get 0. If you plug in 2, you get 0. If you plug in negative 1, you get 0. Okay, next question. Find all of the relative extrema of the polynomial. So, find all the zeros and the relative extrema. So we're going to solve for the zeros for this one. We're going to start by factoring. So we see that they both have x's and they both actually have 2's. So we can pull out negative 2x squared because they both have that. That'll make this negative though. And then from here we can factor. Negative 2x squared is x minus 1, x plus 1, because negative 1 times negative 1 is 1, negative 1 plus 1 is 0. So now we can factor. We're just going to be looking at the zeros for this question. We'll talk about the extrema tomorrow. But I do want to think about this. X equals 0, x equals 1, and x equals negative 1. This one, though, if we would have set this equal to 0, could have divided by negative 2, x squared equals 0. We're actually going to get 2 answers there, except that they're the same. So this one has what we call a multiplicity of 2. Because there are 2 of that same answer in here. Like it's squared there. These 2, so this one's multiplicity 0, these 2 are multiplicity 1. And all that means is that multiplicity. All this means is that there's just one solution, one of that answer. But because this one was squared, there was 2 of that answer. Okay, last one just wants us to do a graphing utility to find the zeros, so I want to make sure that we're okay with how to do that. Y equals, and we're going to plug it in. X to the 5th minus 3x cubed minus x squared minus 4x minus 1. So once we get that there, I'm just typing it in. We're going to graph it, and my graph is in like a super weird window right now. So we're going to have to figure that out, how to make this look a little bit prettier. I'm going to go to Zoom Fit and see what it gives me. Oops, Zoom. I'm hitting the wrong button. So Zoom Fit. It's loading. We should be able to see. Whoa. Maybe Zoom Fit wasn't so great. So now that we have that, let's try zooming in down here by the x-axis, because that's what we really care about. Is like, where is this crossing the x-axis? We want to find our zeros. Let's try zooming. Let's just try going zoom standard and see if we can see more from here. There's 1, 2, 3 that we're crossing there. So let's go ahead and try that. Second, calculate. Come on, calculator, you can do it. 0. So this is helping me to calculate the zeros. I go to the left of the 0 and to the right of the 0, and then it will tell me that my first 0 is negative 1.86. And now I do it again. Second, calculate 0. I'm going to go on the left, and then I'm going to go to the right of the 0, and it's negative 0.254. And now I'm going to do one more. Second, calculate 0. To the left, to the right. And my other 0 is 2.114. Well, this has an exponent of 5. So why do we only have three points here that we're crossing at? These would have a higher multiplicity than some of them, or we would have non-real solutions. But these are our 3 values. As we zoom out of the graph, you can see that those are the only 3 points crossing the x-axis. Thank you.